In this video, I'm going to go through question 1 from the homework on volume. So you're asked to find the volume of these shapes in question 2. So starting off, we have a sphere. It has a diameter of 20 millimeters, which means the radius is 10 millimeters. So you start off with your formula of 4/3 pi r cubed. Sub in your radius of 10, you'll end up with 4,188.79, which rounds to 4,189 millimeters cubed. For part B, you've got a cone. And what's really important here is that you're not given the vertical height, okay? And you need the vertical height in order to work out the formula, or to sub into the formula for the volume. So before you work out the volume, you're going to need to work out what that vertical height is. So if you have a look at that kind of triangle or slice, you've got your radius of 10, the slant of 30, and using Pythagoras theorem you can work out that the height would be 20√2. So subbing in to the formula your radius of 10 and your vertical height of 20√2, you get that your volume is 2,961.9, which rounds to 2,962 millimeters cubed. Crucially important there that you do not use the slant height, you have to use the vertical height. Okay, for part C, this is a cylinder, so you're going to use your formula for the volume of a cylinder, pi r squared h. Subbing in your radius of 3 and your height of 12, you get 339 millimeters cubed. Part D is half a sphere, so you're going to use the formula for a sphere and then get half of it. So your radius from this one is 15 millimeters because the diameter is 30. So subbing in, you've got 2/3 pi times 15 cubed, which gives you 7,068.58, which rounds to 7,069 millimeters cubed. So for part E, you've got a quarter of a sphere. So you're going to work out the volume of the sphere and get a quarter of it. So there's the volume of a sphere and then getting a quarter. And you can see that those two fractions simplify to give you a third. So subbing in our radius of 12 millimeters, you get 1,809.55, which rounds to 1,810. Okay, for part F, we have half a cylinder. So you're going to write down your formula for the cylinder and get half of it. Our radius here is 12 millimeters because you can see that the whole distance across is 24. So our radius is 12 and our height is 32. Subbing into the formula gives you 7,238.229, which rounds to 7,238 millimeters cubed. For part G, we have half a cone. Again, we've been given the slants. We've given the radius, but we haven't been given the vertical height, so you're going to need to work that out. So if you take, I suppose, this here, I'll try highlight it in red here. So we're looking at that in terms of a right angle over here, and you end up with the vertical height of 24 when you use Pythagoras theorem. So we have half our cone, so we have half our volume for the cone. Subbing in our radius of 10 and our height of 24, we get 1,256.63, which rounds to 1,257 millimeters cubed. Okay, so part H is a prism, so we're going to work out the area of the cross section, which is on top there. So that's a triangle, so it's going to be half of 12 times 16. You can see that they're perpendicular there. And then multiply that by 11 because that's the, I suppose, the length of the prism, and that gives us 1,056 millimeters cubed. Part I is also a prism. You can see that this is a trapezium. So in order to work out the area of the cross section, you need the formula for a trapezium. So that was A plus B over 2 times H, if you remember. So we have our long side is 14, our short side is 10. Add those together, divide by 2, and then multiply by the height, which is 4. So the first part of that formula there is literally just working out the area, and then multiply that by 3 because that's the length. So we have 144 millimeters squared. Question 12. A solid sphere just fits into a cubical box as shown. If the edges of the box is 14 centimeters in length and taking pi as 22/7, find the volume of the box in centimeters cubed, the volume of the sphere in centimeters cubed, and the percentage of space not occupied by the sphere. Give your answer correct to the nearest integer. So first of all, we're asked to find the volume of the box. So that's just going to be 14 times 14 times 14, the length times width times height, which is 2,744 centimeters cubed. Okay. For part B, the volume of the sphere. So you're going to write down your volume for the sphere, and because the length of the square is 14, half of that will give us the radius of 7 centimeters. So subbing it into your volume of the sphere's formula, you get 4/3 pi 7 cubed. They want us to use 22/7 as pi in this question. And when you use that, you'll get 1,437 1/3 centimeters cubed. So for part C, to find the percentage of space not occupied by the sphere, you subtract the occupied space away from the total space to give 1,306 2/3 centimeters cubed. So percentage of unoccupied is going to be your unoccupied space over your total space and then multiply by 100 to give you 47.62%, which works out to be 48%. Okay. So the same sphere fits exactly into a cylinder. So you have some kind of cylinder, okay, and I'm going to do my best to sketch this, inside which that same sphere is going to fit. So it fits in perfectly, so there's no space either side. So our radius for the cylinder is 7 centimeters and the height of the cylinder is 14 centimeters. Okay, so we're keeping the same radius, we're keeping the same height, then will be 14. So thinking about our formula for the volume of a cylinder, we have pi times the radius squared times h. So sub in your 7 for your radius and your height of 14. Now, remember in this question they want us to use 22/7. So what you'll end up with is 2,156 centimeters cubed. So there's a bit of a mistake there in the question. So that gives you the volume of the cylinder. We know that the sphere is the occupied space. So if you subtract the occupied space of 1,437 1/3, what you'll end up with is 717 point something. Now just bear in mind, for some reason they've decided to not use pi or 22/7 for pi here, so the answer is going to be a little bit off. So I'm just going to write in 2156 and subtract my 1,437 1/3, and what I should get there is 718 2/3. Okay, so just forgive the mark scheme, it's not doing what it's meant to. So then the percentage of unoccupied space is 718 2/3 over 2156, which gives 1/3. Okay, so that actually did work out correctly there. So less space is occupied if you were to use a cylinder. So that's kind of a good question for manufacturers. If they were trying to package something, you would be better off using a cylinder than using a box if you were trying to package a sphere. Okay, I hope that's helped. There was a few mistakes in the mark scheme, but we got there in the end. Okay, question 13 asks us to find the volume of this shape. Now we haven't covered a formula for this, so we're going to use our imaginations to a certain extent. So imagine that shape has been made from two cones. So you build this larger cone, okay, work out the volume of that, and then come along and work out the volume of this smaller cone and remove it. So you're going to find the volume of the large cone and then subtract the volume of the smaller cone. So that seems like a fairly simple concept, except when it comes to working out the volume of a cone, we need to have the height, and we do not have the height of either the large cone or the smaller cone. So we're going to have to work that out. So we're going to focus our attention on this two-dimensional triangle, which you can see over here. Now, we have 7 at the top, we have 3 there parallel to it. We have the height of the shape given is 6. So if we were trying to find the total height of that imaginary cone, we could call that h, which means that the part of the cone we don't have would be h minus 6. Okay, so that would be the other part. So 6 and h minus 6 would give us the total height. So what we can use now is our similar triangles to help us work this out. We covered this in geometry a few weeks ago. So we have a large triangle with a height of h and 7 on that length. And then we have a smaller triangle, which is this one here. Okay, and that is going to be h minus 6 with 3 there. Now the relationship of 7 to 3 has to be the same as the relationship of h to h minus 6. So by doing a little bit of manipulation there, we get 7 h minus 6 equals 3h, so I've just multiplied across, and then we get 7h minus 42 equals 3h. Bring across 3h gives us 4h minus 42 equals 0, 4h equals 42, so h equals 10.5. And you can see that over here as well. They just went about it a slightly different way to me. So now that we have that, we know that the volume of the large cone is 1/3 pi r squared h, so then your radius of 7, because that's the radius of the base of the cone, and then your height of 10.5. So you get 171.5 pi centimeters cubed. They haven't worked out either. For the small cone then, the base of the small cone, that kind of cone that we're going to cut away, is 3 centimeters, and the height of that cone, remember the height was h minus 6, so that's 10.5 minus 6, so that's why we have 4.5 there. So that works out to be 13.5 pi. So the stopper is the 171.5 pi, take away the 13.5 pi, which leaves you with 158 pi, and that works out as 496.4 centimeters cubed to 1 decimal place. So really good question to learn from. I definitely gave you a challenge with it, so don't worry if you didn't get it, but definitely take on board some of the things that I've gone through in the video. Okay, thanks a million everyone.